My class of cloud computing. Today we will learn about virtualization of CPU, memory, IO devices. Virtualization is basically making a virtual image or version of something such as server, operating system, storage devices, or network resources so that they can be used on multiple machines at the same time. The main aim of virtualization is to manage the workload by transforming traditional computing to make it more scalable, efficient, and economical. Virtualization can be applied to a wide range such as operating system virtualization, hardware level virtualization, and server virtualization. Virtualization technology is hardware reducing, cost saving, and energy saving. Virtualization technology is rapidly transforming the fundamental ways of computing. Sorry. In cloud computing space, memory is virtually allocated to the users in servers which require a host or platform on which hypervisor software which interacts with the hardware. The virtualization model is consisting of cloud users and the host, which is a platform. The virtualization model consists of service model, virtualized model, and its host software, and as well as their hardware. Virtualization software makes it possible. Virtualization software makes it possible to run multiple operating systems and make it possible on the same server at the same time. As director of VMware, a pioneer company, has pointed out, virtual server seeks the permission of operating system. By maintaining virtual server, we can reduce the service of cloud providers, merit and IT potential maintenance, high availability of hardware, deployment of servers in virtually based environment. Aggregators of resources. The small resources which are available can be increased at large extent with the help of virtualization. Benefits of virtualization technology: it is one of cost saving, hardware reducing, and energy saving technique. It helps to make cloud computing more efficient and eco-friendly, and a big step towards new technology making life easier and better. Resource sharing, aggregation of resource, dynamical resources are some of the benefits. A virtual machine is a duplicate of an existing computer system in which a majority of the virtual machine instructions are executed on the host processor in native mode. Thus, unprivileged instruction of virtual machines run directly on the host machine for higher efficiency. Cloud computing provides a lot of benefits to users and makes the work much easier, and some of the key benefits are pay just for service, on demand self service, resources are shared, business is the main focus, accessible all over the world, data is secured. Some of the major problems or major challenges which are faced by using this technology are mass data loss, infected application, and data integrity. If some calamity hits the data center, then it might destroy the data stored in the data center or might shut down servers. Infected application: if a virus is infects one file, that it may corrupt whole system. The integrity of data can be affected as anyone can access it from anywhere. So there are always a chance of affecting the integrity of data. Privileged instruction of virtual machine run directly on host machine for higher efficiency. The critical instructions are divided into three categories: privileged instruction, control sensitive instruction, behavior sensitive instruction. Privileged instruction execute in a privileged mode and will be trapped if executes outside this node. Control sensitive instruction attempts to change the configuration of resources used. Behavior sensitive instructions have different behavior depending on the configuration of resources, including the load and store operation over virtual memory. A CPU architecture is virtualizable if it supports the ability to run the virtual machines, privileged and unprivileged instruction in the CPU's user mode, while the VMM run in supervisor mode. When the privileged instruction, including control and behavior sensitive instruction of a virtual machine, are executed, they are trapped in VMM. RISC CPU architectures can be naturally virtualized because all control and behavior sensitive instruction are privileged instruction. Hardware assisted CPU virtualization. Processors with virtualization technology have extra instruction set called virtual machine extension or VMX. There are two modes to run under virtualization: root operation and non-root operation. Usually only the virtualization controlling software called virtual machine monitor VMM runs under root operation, while operating system running on top of virtual machine run under non-root operation. Software running on top of virtual machine is also called guest software. To enter virtualization mode, the software should execute the vmxo on instruction and then call the VMM software. The VMM software can enter each virtual machine using VM launch instruction and exit it by using VM resume. VM stands for virtual machine. If virtual machine monitor wants to shut down and exit virtualization mode, it executes the vmx off instruction which shuts down the machine. Virtual memory virtualization is similar to virtual memory support provided by modern operating system. In a traditional execution environment, the operating system maintains mapping of virtual memory to machine memory using page table, which is one stage mapping from virtual memory to main memory. All modern x86 CPUs include a memory management unit and a translation look aside buffer to optimize virtual memory performance. In virtual execution environment, virtual memory virtualization involves sharing the physical system memory in RAM and dynamically allocating it to a physical memory of virtual memories. Guest OS sees flat physical address space. Page table within guest OS translates from virtual to physical address. Second level mapping does or performs or changes physical address to machine address. VMMs can swap virtual machines page to disk. Traditional way to have the VMM maintain the shadow of the virtual machine's page table. This shadow page table controls which pages of machine memory are assigned to a given virtual machine. When OS updates its page table, VMM updates the shadow. This is done to updating of the shadow. However, care should be taken so that efficiently virtualize the CPU to provide illusion of multiple machines, retain control of physical machine. Bare metal architecture is one of the example where hypervisor installs directly on hardware, provides its own device driver, acknowledged as preferred architecture for high-end users. So this is the example of CPU utilization. There are several reasons why CPU utilization is needed. CPU virtualization uses it to integrate server hardware by moving services on separate server. It provides security to the hardware resource which harm by distrusting users. CPU virtualization used for virtual hosting environment. It can separate several applications into container. This is the diagrammatic representation of CPU virtualization. How to virtualize CPU resource? Virtual machine is set one or more vCPUs and each vCPU is allocated to run applications of guest operating system. Each application program is denoted by an ordered set of instruction and finally executed by physical CPU. During the running of application, app instructions will firstly submitted to vCPU, that is virtual CPU. Then the vCPUs are mapped to or allocated with physical CPU to run instruction through virtual memory machines VMM. App instructions virtual machine 0 to virtual machine n, and all of them or mapping is being done under the supervision of VMM to CPU. How operating system acts in CPU virtualization. We can take the study of Linux operating system virtualization or Windows operating system virtualization as case study. VMware Workstation software is used to virtualize Linux system. In addition to install any software by the means of virtualization, the user will need VMware software to install first. Windows operating system virtualization is also similar to the Linux operating system virtualization. To install any software, that is a need to install VM software directly. There are two types of virtual disk present in operating system virtualization so that client can connect via the network to the virtual disk. One is private disk, another is shared disk. The private disk utilizes by a single client or single organization. In this disk, the company can store the information based on the capability assigned, whereas shared disk used by multiple clients at the same time, the changes done by the client are applicable individually and won't affect the settings of another client. That caches get cleaned when the system is restarted. It will set to default after the system gets a restart. What are the advantages? As there is no hardware required, the maintenance will be less and therefore it saves both time and money. The number of machines will be late, so there will be lower power consumption, lower cooling requirement, low maintenance and more electricity savings. It also allows the company to make enhancement in terms of efficiency to use the server hardware, and thus there is greater return of investment ROI on the purchase and greater operational works. This virtualization has quick deployment capabilities and the traditional environment. In the traditional deployment, every machine needs to load individually, which is not a problem in operating system virtualization. This virtualization allows security and locates final IT hardware resource among a large number of mutually distrusting users. Moreover, it uses for consolidating server hardware. In this virtualization, the operating system may hide the resources so that when the computer program reads it, they do not appear in the enumeration result. Here it is also possible to run the program within the container to which only parts of these resources are allocated. These are the types of CPU virtualization: software based, hardware based, processor specific behavior, and performance implications. These are different types of CPU based virtualization, each having different characteristics. A virtual machine is a duplicate of an existing computer system in which a majority of virtual machine instructions are executed on the host processor in native mode. Thus, unprivileged instruction of virtual machines run directly on the host machine for higher efficiency. Other critical instructions should be handled carefully for correctness and stability. The critical instructions are divided into three categories: privileged instruction, control sensitive instruction, behavior sensitive instruction. Privileged instruction execute in a privileged mode and will be trapped if executed outside this mode. Control sensitive instructions attempt to change the configuration of resources used. Behavior sensitive instructions have different behavior depending on the configuration of resources, including the load and store operation over the virtual memory. A CPU architecture is virtualizable if it supports the ability to run the virtual machine's privileged and unprivileged instruction in the CPU's user mode, while the VMM runs in supervisor mode. When the privileged instruction, including control and behavior sensitive instruction of a virtual machines are executed, they are trapped in the virtual machine monitor. In this case, virtual machine monitor acts as a unified mediator for hardware access from different virtual machines to guarantee the correctness and stability of the whole operating system. Next one is hardware assisted CPU virtualization. This technique attempts to simplify virtualization because full or para virtualization is complicated. This technique removes the difficulty of implementing binary translation of full virtualization. It also lets the operating system run in virtual machines without modifications. Generally, hardware assisted virtualization should have high efficiency. However, since the transition from the hypervisor to the guest operating system incurs high overhead switches between processor modes, it sometimes cannot outperform binary translation. Hence, virtualization systems such as VMware now use a hybrid approach. Third one is processor specific behavior. Virtual memory utilization is similar to virtual memory support provided by modern operating system. In a traditional execution environment, operating system maintains mapping of virtual memory to machine memory using page tables. That means A two-stage mapping process should be maintained by the guest OS and the virtual machine monitor. Advantages of CPU virtualization. If we take the case study of advantages of Linux virtualization, we can say that better utilization of resources, reduced management, flexible, reduces other expenses. So we can say that CPU virtualization is cost saving. Next is memory virtualization. Memory virtualization decouples volatile random access memory. It is similar to virtual memory support provided by modern operating system. In a traditional execution environment, the operating system maintains mapping of virtual memory to machine memory using page table, which is a one-stage mapping from memory to machine memory. However, in a virtual execution environment, virtual memory virtualization involves sharing the page system memory in a RAM and dynamically allocating to the physical memory of virtual machines. That means a two-stage mapping process should be maintained by the guest operating system and virtual machine monitor respectively. The distributed pool can then be utilized as a high secured cache, a messaging layer, or a large shared memory resource for a CPU or GPU utilization. Since each page table of guest operating systems have separate page table, the physical memory address are translated to machine address by maintaining a set of page tables for every process. The shadow page table will get flooded. VMware uses shadow page table to perform virtual memory to machine address translation. This is the diagrammatic representation of memory virtualization. Shadow page table is there, which is virtual machine, and virtual machine monitor controls the working of shadow page table. Physical memory to reset page table is done in memory management unit, whereas virtual machine monitor controls the working of virtual physical memory. This is the diagrammatic representation of virtual memory virtualization. Input-output virtualization involves managing the routing of I/O requests between virtual devices and the shared physical hardware. At the time of the study, there are three ways to implement I/O virtualization: full device emulation, para-virtualization, and direct input-output. Full device emulation is the first approach for I/O virtualization. Generally, this approach emulates well-known real-world devices. All the functions of a device or bus infrastructure, such as device enumeration, identification, interrupts, and DMA, are replicated in software. This software is located in virtual memory monitor and acts as virtual device. This is the diagrammatic representation. The full device emulation approach is shown in this diagram. Guest operating system, device driver, device emulation, IO stack, and device driver are present in virtualization layer. These are the this is the at the bottom is real device. It may be different from input output device. A single hardware device can be shared by multiple virtual machines that run concurrently. However, software emulation runs much slower than the hardware it emulates. The para-virtualization methods of I/O virtualization is typically used in Xen. It is also known as split driver model consisting of a front-end driver and back-end driver. The back-end driver is running in domain U and the back-end driver is running in domain 0. They interact with each other via a block of shared memory. The front-end driver manages the I/O request of the guest and the back-end driver is responsible for managing the real input-output devices and multiplexing the I/O data of different virtual machines. Direct input-output virtualization lets the virtual machine access devices directly. It can achieve close to native performance without high CPU cost. However, current direct I/O virtualization implementations focus on networking for mainframes. There are a lot of challenges for commodity hardware devices. For example, when a physical device is reclaimed for later reassignment, it may have been set to an arbitrary state. That's all about input-output virtualization. Thank you for watching.